Lesson 27 is one of our more on lessons. We're going to have more on the distributive property. And really just means it's going to get a little bit more complicated, but just to back up and review, the distributive property is a very useful property, especially in mental math. The way that it works is there'd be the traditional way of solving this, where we would simplify what's in the parentheses first and say this equals 4 times 5, which is 20. That would be kind of the traditional way of solving it. The distributive property says it will work just as well if we distribute the 4 through this. Since parentheses indicate multiplication, we can multiply 4 times 2, which is 8, and then distribute 4 times 3, which is 12. 8 plus 12 equals 20. Either way, we get an answer of 20. The reason we have to use the distributive property, one of the reasons is because with variables or unknowns, we don't know the value. And so if we have 2 times the quantity a plus b, we can't add a and b because they're not like terms. We have no idea what they are added together. So we simplify this by distributing 2 through. So 2 times a is 2a, and then 2 times b is 2b, so we have 2a plus 2b. And I guess I'm going to pause it right here and kind of get off track a little bit before we get to our next example, because the book doesn't get into it yet in this lesson. But the question you should be asking yourself is, why? Why would I want to do that? What advantage is there to having this written like this? Why not just leave it as 2 times quantity a plus b? Is this a better form? No, it's not. But there's an advantage, and the advantage is we want to be able to eliminate our parentheses. Sometimes we want to be able to eliminate the parentheses. I'm getting distracted by a fly here that is driving me crazy. Sorry about that. And here's an example where we might want to eliminate parentheses. Let's say we have 2 times the quantity a plus 4 equals 6. And my directions are solve. So I have to solve this. Well, I can't add a and 4. And so if I can't add a and 4, at this point I'm stuck, aren't I? Because if I only use the traditional way of solving something with parentheses, I add and then multiply. Well, in this case, I can't because they're not like terms. But what I can do is I can eliminate these parentheses so that I'm not stuck anymore. Otherwise, I really can't do anything. So I distribute through, and I've got 2a plus 8 equals 6. And now what I've done is I've eliminated parentheses. And now I can keep going and solve the equation. Subtract 8 from both sides. Subtract 8, 2a equals negative 2a equals negative 1. So I was able to solve that by eliminating the parentheses, and that's going to be important later on to be able to eliminate parentheses sometimes. And the odd thing is sometimes too we're going to actually want to create the parentheses. We're going to have 2, for example, we'll have 2a plus, what do we have here, 8, once I distribute it through. And you'd say, well, sometimes I want to reverse the distributive process, and you'd say, well, why would I want to do that? Well, if this were 2a plus 8 over 2, excuse me, by reversing the distributive process, we would end up with a 2a plus 4 over 2. And since this is multiplication, I could reduce. So this all equals a plus 4. Excuse me again. So sometimes we'll want to eliminate parentheses, and sometimes we'll actually want to create parentheses, depending on the problem itself. But for today, neither of those are really important. They just want us to practice with the distributive property, especially with variables or unknowns. Here's another example. xy times the quantity y squared minus x squared z. To distribute this through, we would have x y to the third. It's not like adding like terms. When you're multiplying, bases are the same. This is like y to the first. Y and y, you add the exponents. Add the 2 and the 1. When bases are the same, add the exponents when you're multiplying. Next term, xy times negative x squared z. We would end up with x to the third y z. This is, whoop, kind of cut my 3 off there, the simplified form of this. Here we've got a mix of numbers, what we would call a coefficient, and variables. Distribute through, everything gets multiplied. We end up with 4x to the 5th, because x to the 4th times x. This is like x to the 1st. Bases are the same, x and x. Add the exponents, 1 and 4, x to the 5th. Again, y to the 3rd times y to the 1st. Bases are the same, y and y. Add the exponents, 3 plus 1, be y to the 4th. Minus, here we've got 4 times negative 5. I've already got the negative sign there. I knew it was going to be a negative. And then this becomes x squared, y to the 3rd. What did we accomplish? Well, we accomplished eliminating the parentheses. That was our goal. It's building up to something else. Finally, notice here an example where we've got 3 terms inside the parentheses. Distributive property says doesn't matter if there are 2, like we've done before, or 3, 4, 5, 6, does not matter. Just make sure you distribute the number on the outside of the parentheses to every single term. So first term we would have 40 m to the 5th x squared. Second term would be negative 24, 8 times 3, m squared x to the 7th. And then finally plus 16 m squared x squared. We eliminated the parentheses. And the second half of the lesson, I know we covered this. I think it was when we were just solving equations earlier. I remember going through a problem and saying, well, when you end up with decimals sometimes, we can solve this just using our inverse operations. We could subtract 0.4 from both sides. And then when we were done, we would have 0.02 m equals 4.2. And then we'd divide by 0.02. And we'd say, okay, 4.2 divided by 0.02. Move the decimal 2 places over. Move the decimal 2 places over. Let's pretend these aren't here. I'll X them out. And we'd end up with 2100. 2100. But if we go back to the original problem, sometimes it's easier to eliminate the decimals right off the bat. And the way we would do that is we would multiply these by powers of 10. I think I drew something like this in one of the lessons. If I multiply each of these by 10, we get 20 plus 40 equals 60. It's still true. If I multiply each of these terms by 100, so all of them times 100, you'd get 200 plus 400 equals 600. So it does not matter how many or what multiple or power of 10 I multiply them by, it's still going to be an equation. And that's the important thing. It's still going to be equal. So I'm going to do the same thing here. I'm going to look at how many, for each term, which term has the most decimal places. Here I've got 1, here I've got 2, and here I've got 1. So I'm going to multiply, take the greatest one, say I'm going to multiply to eliminate the decimals here. I'd have to multiply it by 100 to eliminate the decimals, because I'm going to move it 2 over. So if I multiply them all by 100, I learned that I'll still have an equation. And that's the important thing. I changed the numbers, but I still have an equation. And I tested that over here and saw that it worked. So now I end up with 40 plus 2m equals 460. So now, some people prefer this. It looks cleaner than with the decimals. Work to get m by itself. M equals, subtract 40 from both sides, and we've got 2m equals 420. I can tell already I must have made a goofy mistake or a stupid mistake in my quick run through with this decimal, because I ended up with, I think, 2100, and we're going to see that it's 210, so I must have added a 0, so I apologize for that with the example. But nonetheless, hopefully you see how this works. Simplify this down to 1 times m, which is m, and 420. See, goes in there 210 times. You would not have to do this problem this way. You could have left it in the original form and you would have gotten the exact same answer, 210, unless you made a careless mistake like I did. But there is an advantage, I think. If nothing else, some people just prefer to multiply by powers of 10, enough powers of 10 that you eliminate the decimals.